Hey pre-calc students, welcome to today's lesson on composition of inverse functions involving special triangles. So everything that you see on your screen right now is a review of what we've been talking about when it comes to inverse sine, inverse cosine, and inverse tangent. They are restricted to certain quadrants, and it's also important to remember that it's not just the quadrants that will help us find the answers. It is also the degree measures that are important. So when it comes to sine inverse or inverse sine, remember that you can go down to negative pi over 2 or up to positive pi over 2. And these are negative 90 or positive 90 degrees, okay? When it comes to cosine, it could go from 0 to pi, right? In degrees, that would be 0 to 180. And then these restrictions are the same for inverse tangent. Along with that, it is going to be important for you guys to remember the properties of quadrantal angles, the ones that land on the x or y axis, and the fact that their coordinates are cosine comma sine. Tangent, remember, is the ratio of sine over cosine, y over x, and cotangent, which is its reciprocal, would be cosine over sine, x over y. All right, so the problems that we're going to be dealing with are going to be two problems in one, okay? So that's the difference between what we've been doing and what we're going to do today. So we're going to have two problems in one, and you want to work from the inside out. But what's critical with these problems is you need to pay attention to whether you've been given a ratio or you need to find the ratio. So again, when you're given a ratio, okay, that means that they're probably trying to find the angle, right? Because you already know the ratio. So you'll see something like sine inverse of a ratio, and then your job is to find the angle. Vice versa, right? Or if you think of it the other way, if you are given an angle, then you're going to be asked to find the ratio. So if they're asking you for the sine of pi, they're asking you for a ratio, or sine of pi over 4, right? Then you're going to be asked for the ratio. That would be opposite over hypotenuse. And again, the trig function can vary. It could be sine, cosine, tangent, their inverses, or even their reciprocals. But again, when you're given a ratio, your job is to find the angle. And when you're given an angle, your job is to find the ratio. So we know that some of you are more fluent when working with degrees, but today we're going to focus on radians, okay? So quick reminder that 30 degrees is pi over 6, 60 degrees is pi over 3, and 90 degrees is pi over 2, okay? So feel free to write down these triangles on your piece of paper or keep it on a note card for quick access. Okay, so we do expect you guys to be able to do all of these problems without a calculator. And one of the things that is really important is for you to have a fully labeled diagram, always. That's how you're going to show your work, okay? All right, so let's take a look at the first example. It's two problems in one. We're going to work from the inside out, in this case from right to left, okay? So we're going to focus first on finding the innermost answer, sine of 4 pi over 3. So I'm going to just rewrite that over here to keep myself organized. Sine of 4 pi over 3. Okay, so 4 pi over 3 is going to land. So I'm cutting into 3 sections, right? Because the denominator is 3, so 3 equal parts. As equal as you can make them. Obviously, mine didn't turn out so good. That's why we always recommend that you guys write with pencil so you can erase. Okay, so this is 1 pi over 3, 2 pi over 3, 3 pi over 3, which makes sense because that should always reduce to pi. So then here's 4 pi over 3. Okay? All right, so I'm going to go ahead and zoom in here. So 4 pi over 3 ends up in quadrant 3. Okay, so this is a full angle, but we're going to focus on the special triangle created by the terminal side to the x-axis. So what is the reference angle of 4 pi over 3? Well, how far is 4 pi over 3 from the x-axis? And remember, you want the lowest distance. So it is 1 pi over 3 as the reference angle. Okay, so reference angle is 1 pi over 3. That's 60 degrees. Across from the 60-degree angle is root 3, but in this case it's going to be negative because you went down. Then this would mean that this is 30 degrees, and across from 30 is a 1, but again you went left from the origin. So imagine the origin, right? The y-axis would be right here. Okay, so, and then the hypotenuse would be 2. Okay, so the sine of 4 pi over 3 would be, using your reference angle of pi over 3, you would do opposite over hypotenuse. So that's negative root 3 over 2. Okay, that equals negative root 3 over 2. So now I'm going to go back and pretty much put that into the original problem. Okay, so now we're slowly evaluating this. Okay, so now it's cosine inverse of negative root 3 over 2. I just realized I might have said that wrong previously. So negative root 3 over 2. I hope I didn't say pi. Yikes! Okay, so now we are given the ratio and we need to find the angle, right? Because they're saying what angle, so what angle, that's cosine inverse, what angle has adjacent over hypotenuse that equals negative root 3 over 2? That's what they're asking us. Well, let's think back to what quadrants we're limited to, right? Because, okay, so remember, this is our job now, right? We're trying to find cosine inverse of root 3 over 2, of negative root 3 over 2. We are restricted to quadrants 1 and 2. Okay, for cosine inverse. But because it's negative, we're not going to use the special triangle in quadrant 1. We're going to use the one in quadrant 2. You'll see why in just a second. It has to do with the side lengths, okay? So we want to figure out what angle has adjacent over hypotenuse of negative root 3 over 2. Now remember, when you go left from the origin, that side length is going to be negative. So we want negative root 3 over 2. That means the one goes here. So what angle has root 3 adjacent to it? That's 30 degrees. But we're dealing with radians, so that's pi over 6. That means this is 60. Oopsies. I just realized I put pi over 6 when it should have been pi over 3 for 60 degrees, right? Our brains just tend to do that, associate things, right? So we think pi over 6 is 60. Nope, pi over 6 is 30 degrees. Now, if I had set it up in quadrant 1, the root 3 would have been positive, and that's not what I'm looking for. Right? I needed the ratio to be negative root 3 over 2. Okay, so remember, pi over 6 is just the reference angle. So in this particular case, the reference angle is pi over 6. Cosine is restricted between 0 and 1 pi, which in this case would be, if the reference angle is pi over 6, that would be 6 pi over 6. So I'm trying to find out what angle is this obtuse angle that ends up in quadrant 2. Okay, so the answer is not pi over 6. The reference angle is pi over 6. That angle is 5 pi over 6. Now remember, you can rewind, you can pause the video, watch it again, right? Watch an example again. But in essence, we are combining everything we've been doing just step by step. And a composite problem. It's a composition. It's made up of two things. All right, so we want to work from the inside out, right to left. So cosine of pi, they've given me the angle already, so they're asking me for cosine, right? Cosine is adjacent over hypotenuse for when you're dealing with right triangles, but in this case, think about it. Where is pi? Okay, so right now I'm focused on finding cosine of pi. Pi is a quadrantal angle, which coordinate has coordinates of -1, 0. So I can't do adjacent over hypotenuse the way I normally do. Instead, I'm going to think to the idea that cosine is the x value of my coordinate since it's a quadrantal angle, right? So cosine of pi is -1. So now I'm going to look at the original problem and replace cosine of pi with -1. I'm going to finish the problem. So let's think about what this means. This is asking you what angle has opposite over adjacent that equals -1/1. So I'm going to write it as a ratio, okay? So they've given us a ratio, which is -1 or -1/1, and they're asking me tangent inverse. So they're asking me for the angle. All right, so for tangent inverse, you are restricted to quadrants 1 and 4, but more specifically, you can go up to positive pi over 2 or down to negative pi over 2. Because of that negative, I'm leaning more towards quadrant 4. Okay, so again, you can draw both triangles, but in this case, for opposite over adjacent, because we want it to be negative, the ratio, we're going to lean more towards quadrant 4 because that's the one that can give us a negative value. Okay, so we want opposite over adjacent to be -1/1. So that reference angle, now I'm going to just kind of fill in the rest. This comes from a 45, 45, 90 triangle. So the reference angle is pi over 4, but again, we want the angle that is in quadrant 4. So we're going to be focusing on the one that goes down pi over 4, okay? All right, so if I specifically look, right, this is what I wanted. I wanted opposite over adjacent to be -1. The reference angle is pi over 4, but according to the restrictions, my angle could be positive pi over 4 or negative pi over 4. So positive pi over 4 wouldn't give me the -1/1. That would be positive 1/1. So it can't be this one. It's got to be negative pi over 4, the one that ends up in quadrant 4 and goes down. Okay, so remember we're working from the inside out. Feel free to always pause the video when you need to. All right, so I'm going to focus on finding the cotangent of pi over 2. That's a quadrantal angle. Pi over 2, right, is right here. So the coordinates there are 0, 1. Now, cotangent is the reciprocal of tangent. Okay, so we know that tangent is sine over cosine. So that means that this is going to be cosine over sine. Cosine of pi over 2 over sine of pi over 2, which in this case is so tangent is normally y over x, right? So that means cotangent is x over y. So I'm going to want the x value over the y value, which gives me 0. So now I'm going to go back and replace that into the original problem. And I'm going to think of the inverse sine, which is restricted to quadrants 1 and 4. But because they gave me a value of 0, I'm thinking it's going to be a quadrantal angle, right? Because you can't have a ratio of 0 when you're working with right triangles or the special right triangles. So let's take a look at the ordered pairs. So again, I knew it was going to be quadrantal because you can't create a ratio that ends up simplifying to 0 when you're looking at the special right triangles. Okay, remember back that sine inverse is referring to the y value of the coordinates. Sine is the y value of the coordinates. So I'm trying to figure out which of these angles within the restrictions of sine inverse, which are quadrants 1 and 4, which one has a y value of 0? This guy. So remember, according to the restrictions, your sine inverse can go anywhere down to negative 90, aka negative pi over 2, or up to positive 90, in this case, positive pi over 2, right? So it could go down or up. In this case, it doesn't have to go anywhere. It stays exactly where it is. So the answer is 0. 0 radians or 0 pi. That would be an acceptable answer. All right, hopefully you're getting the hang of this, right? So you're always going to work from the inside out, and then once you find the inner answer, you're going to replace it to evaluate the outside function. So they've given me an angle, right? They're asking for the sine. Sine is opposite over hypotenuse. So I'm going to graph the angle, negative pi over 6. That means I need to split each top half of the x-axis and bottom half of the x-axis into 6 equal parts. So this is negative 1 pi over 6. Okay, so I'm going to zoom in because I made it really tiny. Feel free to just redraw the triangle, okay? So this is the triangle we're focusing on with a reference angle of pi over 6. Remember, reference angles are never negative. Okay, so pi over 6 is 30 degrees. Across from 30 is a 1, but because we went down below the x-axis, that's going to be negative 1. That means this is 60 degrees, which is pi over 3. That's going to be positive because we went to the right into the positive x values. And so this is your setup with your 90 degrees to the x-axis, from the terminal side to the x-axis. That should always be your 90 degrees. So I'm going to take the sine now. That's opposite over hypotenuse. So opposite over hypotenuse is going to give me negative a half. So I'm going to go ahead and replace that now. Okay. And now we need to find an angle. So cosine inverse has its restrictions in quadrants 1 and 2. But because of the sign of the ratio, which is negative, I'm leaning towards quadrant 2, right? But feel free to draw both. Okay, so which angle has adjacent? So what angle has cosine, which is adjacent over hypotenuse, that equals negative a half? Is it 30 degrees, 60 degrees, or 45 degrees? Okay, the correct answer is 60 degrees, which would be pi over 3. So our reference angle here is going to be pi over 3. Okay. That would give me, that's 60, so opposite from 60 is root 3. Adjacent would be 1. Hypotenuse is 2. And then you'd have the same values over here, just with a negative 1. Okay. So this is the angle that we want, the one that ends in quadrant 2. because we wanted the ratio of adjacent over hypotenuse to be negative a half. So I had to go to the left and then use the hypotenuse, okay? So the reference angle is pi over 3. This would be 1 pi, right? But with a denominator of 3, that would be 3 pi over 3. So 1 pi over 3 away from that would be 2 pi over 3. So the correct answer here is 2 pi over 3. So remember, it's an obtuse angle, right? So you can't write the answer as pi over 3 because pi over 3 would be an acute angle in quadrant 1. Okay, so let's take a look at the next one. We've got sine inverse of the cosine of negative 2 pi over 3. So work from the inside out. Okay, negative 2 pi over 3. So negative 1 pi over 3. It would be right here, negative 2 pi over 3. This would be negative 3 pi over 3, etc. Okay, so here's your angle. But we want to draw our special right triangle from the terminal side to the x-axis. So that's your 90-degree angle. This reference angle is pi over 3 because negative 2 pi over 3 is 1 pi over 3 away from negative 3 pi over 3. So remember, pi over 3 is 60 degrees. Across from 60 is root 3, but in this case it's negative. Across from the 30 is a 1, but in this case it's negative. Remember, when the side lengths are to the left or down from the origin, for the legs of the right triangle, those are going to be negative. The hypotenuse is always going to be positive, so you don't have to worry about that. All right, cosine of negative 2 pi over 3, that's adjacent, right, over hypotenuse. So that's adjacent over hypotenuse. And then we're going to go ahead and replace that. Adjacent over hypotenuse. And now we're going to find the sine inverse or inverse sine of negative a half. So sine inverse is restricted to quadrants 1 and 4. But because it's negative, it's going to be the one in quadrant 4. Okay? Okay, so we want the reference angle, right? We need to figure out what it is, but we want opposite over hypotenuse to be negative 1. So you should recognize the 1 and the 2 from a 30, 60, 90 triangle. Across from the 30 degrees is the 1. So this has to be pi over 6. Remember, pi over 6 is 30 degrees. But we want the 1 in quadrant 4. So that means we had to go down pi over 6, which would be negative pi over 6 as our answer for the angle, right? Because you had to go down. Okay, so tangent of negative 5 pi over 4. So I'm going to draw, right? This is the first part, tangent of negative 5 pi over 4. I'm going to draw it out. So cut each top half, bottom half into 4 equal parts. We're going down and around, so negative 1 pi over 4, negative 2 pi over 4, which reduces to a half. Negative 3 pi over 4, negative 4 pi over 4, which reduces to negative pi. That makes sense because 180 is always pi. And then this would be negative 5 pi over 4. So This is our angle, but our reference angle, right? Our reference angle is 1 pi over 4 because 5 pi over 4 is 1 pi over 4 away from 4 pi over 4. So if my reference angle is pi over 4, let me zoom in a little. If our reference angle is pi over 4, then that means that we've got 1 root 2. Just remember that when you go to the left of the origin, that side length is going to be negative. And only the legs of the right triangle are negative. The hypotenuse is never negative. Okay, so tangent is opposite over adjacent. So that is 1 over -1, which reduces to -1. Now remember, that's only half the problem. So now we're going to take our answer of -1 and replace it into the original problem. Okay, so cosine is restricted to quadrants 1 and 2. But as I'm looking at the sine of the -1, I'm leaning more towards quadrant 2. Okay, now here's the thing. This is asking what angle has adjacent over hypotenuse that equals -1 over 1. As I think to my 30, 60, 90 triangles, which are pi over 6, pi over 3, right? Adjacent over hypotenuse for neither pi over 6 nor pi over 3 is going to give me 1 over 1. Nor is the pi over 4, the 45, 45, 90 triangle. Adjacent over hypotenuse is not going to give me -1. So that tells me that this is a quadrantal angle. So I'm going to be focusing on not drawing a right triangle, but I'm going to be focusing on the quadrantal angles within that restriction of 0 to pi, to 1 pi. Okay? All right, so the ordered pairs there are 1, 0, 0, 1, and -1, 0. Cosine refers to the x value. So which angle has an x value of -1? This guy. That angle is pi. All right, guys, what I would like you to do next is I would like you to try number 7 and number 8, okay? I'm gonna have you pause the video, okay? So try 7 and 8. Pause the video when you finish 7 and then check your answer. So I'll show you what the answer is. And then you're gonna push pause again till you finish number 8 and then push play when you're ready to check your answer. So please pause the video and try number 7 right now. Just kidding. Checking to see if you actually paused the video. Okay, so the correct answer for 7 will be -pi over 4. Okay, so the tangent of 7 pi over 4 is -1. So when you do this part, you should get -1. And then the tangent inverse of -1 is -pi over 4. All right, so now pause the video, do number 8, and push play when you're ready to check your answer. Okay, So the correct answer here is 0. The cosine of pi over 2 is a quadrantal angle, and the cosine is the x value of that quadrantal angle. So the cosine of pi over 2 is 0. And they're asking you what angle has a tangent of 0. So if you look at your possibilities within the restrictions, which are the quadrantal angles in quadrants 1 or 4, the possibilities are 0, 1, 1, 0, or 0, -1, right? Tangent is sine over cosine. So what angle has a y value that when you divide it with the x, you get 0? This guy. That's 0 pi or 0 radians. All right, as always, if you have any questions, feel free to reach out to us. We hope you have a good day. Adios.